We are delighted to have Yogesh Tak here as a speaker for this webinar. Let me tell you a few things about Yogesh. Yogesh is currently working as a data scientist at Tesco in the customer data team. He has a total experience of 4 years in the field, starting his career at AXA in 2019. His experience includes working mostly around customer data, segmentation, marketing, CRM, and personalization. He did his graduation in food technology and transitioned to data science later. Now over to you, Yogesh.
So we'll start. Today's session will be about, mapping your career path in data science. So just a heads up, there won't be any coding involved, anything at all. It's just a guide. How can you enter as a fresher, or if you want to transition from one field to data science? I don't know how many of you have read this article. It was published 10 years back in Harvard Business Review that data scientist is the sexiest job of 21st century. But does it hold true in today's age, or in 2023? Is data scientist still the sexiest job of 21st century? Because we have lots of tools now. It's very easy to code because people relate data science with just coding. We have ChatGPT, Google Bard, or Dolly from Databricks. There are lots of large language models which can code better than humans. ChatGPT or these large language models can help you, make the Lego bricks. But as a human being, as a data scientist, you need to join those bricks and make your castle. So ChatGPT can help you write a block of Python code, but you need to know what to do with that Python code, how to make pipelines, how to make apps with it, or do your analysis. So I don't believe that, with ChatGPT and everything, data scientist as a job profile will go away or it will become less popular. It has even become more popular because those large language models are generating even more data, and we need people to analyze that data. They should also know, statistics, little bit of math, should have a great understanding of business. So someone who should be better at statistics than most of the software engineers, and should be better at software engineering and programming than any statistician or mathematician. And that's how you become that unicorn kind of a data scientist. So hard skills depend on, what kind of a data role that you're playing in an organization. And there are a lot more data roles, but in a nutshell, I would describe in these 4 categories: data scientist, data engineer, analyst, and a business intelligence. A full stack data scientist is someone who is familiar with all stages of life cycle, what happens from start to end. You should know everything, little bit of everything, so that you're best suited to solve a particular problem. So how do you do that? Start with business acumen. You should know how to translate technical problems into business problems. How do you communicate your analysis to stakeholders? A CEO or your senior manager or any kind of business person won't understand what kind of model you have built or what statistics you used for doing analysis. They'll be interested in how you communicate what you did. Programming is obviously very important to do any kind of task. Data analysis and exploration. So as a full stack data scientist, you should have curiosity to dig deeper into data. Why something happened? Is it really important? So let's start with if let's say if it's 2017 or 2018, and if I were to start over from beginning, how will I go personally? The first step, I will learn to code. It can be Python or R depending your own interest, but I would highly recommend Python because in the business world, most of the data science teams use Python. R, if you're going into more of a research data science role. So let's say you learned how to code. Let's move to the next step, math and statistics. And most of the people would say, this is the place where people get stuck. But I will recommend not focus on this step too much. You don't need to, solve calculus or probability question on pen and paper. But if you know that, let's say you're using one algorithm, if you know in theory how it works, then that's good enough. Let's say, a company tells you that, we get 100 job applications or let's say millions of job applications. Can you identify how many are fraud, how many are actually relevant? So what kind of path will you take? Is it a classification problem, clustering problem, or regression problem? So these kind of things that you should know. I will never recommend you going and actually solving questions and calculus on pen and paper. Then the third thing is the programming, how everything works. Then you should know about data transformation and exploration. Uh, Most of the companies use SQL or big databases to store their data. Do you know how to query the data? Or let's say big companies will have a different database for, let's say, customer data, different database for what they watch on Disney and Hotstar, what kind of products they buy. Everything is in different databases. Can you join them all together? So you should know how to write SQL query so that you can query the data. Do you know what kind of different databases are out there? So then we move to the next step, data visualization. And data visualization is very important. And depending on company, there will be different tools. For example, one of the companies that I worked for uses Power BI. The other company uses Tableau. You don't need to learn both. Just learn one tool, and it's very easy to transition to a different tool if you know the basics and everything. And then learn about design principles. How do you communicate? Let's say you did some analysis that, okay, this is the reason why my customers are buying a particular product. How do you communicate that to a stakeholder or business people? So you should know how to convert that analysis into good visuals and what kind of visual you will use in what kind of data. Move into a data scientist role as well. Then learn about machine learning. And I won't recommending learning each and every algorithm out there, but learn basics. For example, do you know the difference between decision tree and a random forest? If let's say you have built a model, how do you evaluate a model? Is it working, not working? Or let's say you have built a model where you feed in, let's say, or let's say you built a forecasting model that next 1 week, I will have 1 billion of sales. But how is it working? Can you explain that to a business person? Because they won't trust your model until you can explain them in a very layman terms. That's where model explainability comes into picture. Focus there as well. Learn about big data technologies. Hadoop is one of the good example. You should know how the big data ecosystem works, so that whatever you're doing in your programming, you're not just stuck with the Excel files. You need to know how to work with big data as well. So whatever machine learning, data visualization, whatever you learned before, you should be able to use those concepts in big data ecosystem as well. Any company that you go, you should know the basics of cloud computing. Can you start a virtual machine, let's say, or what kind of storage solution that you will use? And let's say if you're a student, I will highly recommend Azure and AWS. They actually give you free credits, or I think $300 or something, to actually learn these platforms. And there's a huge discount for students if you actually want to get certified as well. I won't recommend you getting certified, rather than I will actually ask you to learn and build projects out of it. That's more than certification. Now I will go towards the soft skills part. And from my experience, Tesco has a very big team, and even my previous company had a very big team of data scientists. But what sets you apart from others? And it's actually soft skills, because most of the people know how to code, how to make great models. But if you can't communicate that to people, then you won't be relevant for that long. So focus on the soft skills. And when I say soft skills, I'll start with the first one. Data storytelling. How do you create a sticky story that your audience is very engaged, or whatever recommendation that you're giving, people will actually act on it? The second I would say is business expertise. Let's say you're amazing in programming, but if you can't attach some kind of a number to it. Let's say if the previous example, I built a machine learning model with 99% accuracy. My CEO won't be interested in it. If I tell him that, I built this model and I'll save 50 million for the company, then that person will be much more interested in my model or what I am doing. So getting a job is like entering a club. Let's say you went one night to a club and you see a long queue before the club, and there is one bouncer who's not letting you enter it. That same thing how companies work as well. There are few job openings and there are thousands of people who actually want to get the job. And every company receives thousands, more than thousands of applications on each job. And that's like, you go to LinkedIn and click on apply now on every job, and then you wait, oh, someone will actually respond. No one will respond. Maybe once in 500 job that you applied, but it's very hard. Okay. But in clubs and jobs, there are more than one way to get in. It's not only just clicking on apply now button. Let's say in club, you know the owner of that club, or you know a friend who works at the club, or you know the bouncer or a DJ. Then you will just call them, hey, can you help me in entering the club? That's what you should do in job search as well. Do lots of internships, because internships are, one pathway to go into a full-time role. That way company can analyze how you work. Do you actually know things that you said that you know? And then they can convert your intern role into a full-time, a job role. So do lots of internships. Go to curated platforms. One is Zuno, which is very curated for internships and early careers. Third thing is network with people. Go and attend lots of conferences. And I'll say my first job I got it through a network. So networking is very powerful. Just go and talk to people. The more people you know, it's easy to get a job or even go ahead in a career. The last thing that I will focus more is on personal portfolio if you want to get your first job. Because when, let's say, I'm working professional, if I go to a next company, I can actually show and talk about my projects in this company. But if you're a fresher, or if you want to transition, you don't have anything to show. So that's where you should build your own personal portfolio. Most of the roles, the business roles or the companies that you work for, I don't think you need a formal degree to enter into a data science role. And I know we talked about hard skills, soft skills, building a career, and it's very overwhelming. I remember when I was doing my food technology degree, and I had no relation or nothing related to data science that I was learning in my college. It becomes very overwhelming. You start learning something and then you get stuck. That, okay, I should learn this before that. It's very overwhelming, but just act on it. And I think you'll do great, because once you start doing it, you'll figure out things. And I'll highly recommend, don't learn through theory and books. Learn by doing it. Use free platforms like Kaggle or Google Colab or Udemy, because those platform actually focuses on applied part. They'll actually teach you how to do things rather than how things work in the background. Once you know how things work, how you do things, you can learn theory later. But I would say start doing it. One of the a resource that I would highly recommend, if you still have your student ID, or you're a recent graduate or still in college, use GitHub Education. It's free resource. You will get free domain names, free credits in cloud services, any kind of data set. There are lots of free tools. As I said before, Tableau is very expensive for organizations, but if you're a student, it's free for you. One of the question is, can I go for data science or ST role after BSc Math? Yes, you can. Again, the data science and ST, software development engineering, is a very different role. As I said, data science work in the business world. Software development is a very different world. So I will recommend you first be clear about what kind of role that you want to go. If you want to go for data science, then yes, you can go after BSc Math. Software development engineering, I would say you need more programming and computer science skills to go.
So Yogesh, thank you for this informative webinar on data science career guide, step to success. Your expertise and engaging presentation style made the session very captivating. The practical tips and step-by-step guidance for the successful career in data science were invaluable. Your dedication in sharing the knowledge is commendable, and students must be feeling grateful for the opportunity to learn from you and look forward to implementing the advice that I've gotten from you. So once again, thank you from my side and from the
Thank,
students.
thank you so much, Ryan.